Knowing if something is moving is useful in many applications. The classic example is security, where an alarm system can detect an intruder moving inside a room so it can notify the police. Another common use is in home and office automation, where you can get the lights to turn on and off automatically depending on whether someone is still in the room, or turning on the floodlights in your driveway as your car approaches. There are several technologies used in motion sensors, each with its own capabilities and price points. Passive infrared PIR or PIR sensors are very common and typically found in home electronics. They detect the heat that is emitted by the body of a person in a room as it contrasts against the background heat. A PIR sensor does not emit any energy, it just sits there and waits for a heat source to enter its field of vision. An ultrasonic motion sensor uses ultrasounds to detect moving objects. Just like bats, an ultrasonic sensor emits ultrasounds at frequencies from 30 kHz to 50 kHz and then picks up their echo. These sensors often measure the time a signal takes to return, and from that it can calculate the distance to the object. Therefore, ultrasonic sensors can calculate both distance from an object as well as whether the object is moving. We'll be looking at ultrasonic sensors in the following lecture. A microwave motion sensor works on the same principle as an ultrasonic sensor, except that instead of ultrasounds, it emits microwaves. They are still relatively cheap, and because microwaves are much higher in terms of frequency than ultrasounds, motion can be detected with a lot more detail. Many microwave motion sensors can determine not only the motion itself, but also distance and speed using the Doppler effect. This is an example of what a microwave sensor module looks like. Of course, the module is covered by plastic cover when installed. In this lecture, we will connect a passive infrared sensor to our Arduino, calibrate it, and turn an LED on every time motion is detected. Let's put together this circuit and test out the motion sensor. We will need the Arduino, 4 jumper wires, the PIR sensor like the HCSR501, 1 resistor at 1 kΩ, and 1 LED. This circuit will detect motion through the sensor and send a signal to the Arduino via digital pin 2. The Arduino will receive the signal and in turn activate the LED via digital pin 13. Remember that the Arduino Uno board already has a small LED connected to digital port 13, so you could choose to not connect yours. While you're connecting the motion sensor, it's a good idea to remove the sensor cover so you can see the pin markings, ensuring that power is connected the right way. Let's have a look at the assembly video. Let's start with the sensor. Let's remove the cap off so we can have a look at the markings and be sure of what the purpose of each pin is. And just plug it anywhere on the breadboard. Then we'll take a red jumper wire and connect the positive voltage line on the breadboard with the 5-volt socket on the Arduino. Now we'll take the black jumper wire and connect the ground socket of the Arduino with the ground line on the breadboard. Next we'll connect power from the sensor to the positive voltage line on the breadboard and do the same with ground. Take a yellow jumper cable and connect the sensor's signal output pin, the middle pin, to digital pin 2 on the Arduino. Now let's move on to connecting the LED. We'll start with this protective resistance. We'll connect it to, with one end to ground on the breadboard. take the LED, and notice the short leg should be connected against the second leg of the resistor, the leg which will convey the lower voltage. Take the longer leg of the LED and connect it to the Arduino digital pin 13. Replace a cap on the sensor, and we're done. We can go ahead and connect the circuit to our computer. Notice that there are two yellow knobs on the side of the sensor. One of them can be used to calibrate the sensitivity of the sensor, and the other one the amount of time that the sensor will remain at a high state after it detects motion. There you go, the sketch was uploaded. Now the sensor can detect my body as a source of heat and turns the LED on. Done with the assembly. Let's have a look at the sketch now. For now, the sketch should be easy to read and understand. We start by setting constants for the pins and values. The LED is connected to digital pin 13 and the sensor's output to digital pin 2. We also assume that when the Arduino starts, there is no motion, so variable PS state is set to low, and val, the variable to which the output state of the PS sensor is stored, is 0, which is low. In the setup function, we set pin 13 to be output and pin 2 to be input. We also initialize the serial port so we can see text output from the monitor window. In the loop function, we constantly read the value of the PS sensor by using the digital read (input pin) function. This function reads voltage in the range of 0 volts to 3.3 volts, at least for the sensor I'm using, and the Arduino translates that to low and high respectively. If high is detected, the Arduino will set pin 13 to high, and this will activate the LED. If the previous state of the sensor was low, then the Arduino detects this as new motion, so it will print a message to the monitor and set PS state to high. This will prevent the Arduino from continuously printing out that new motion was detected while the actual motion is still continuing. Upload it to see it working. Don't forget to open up the monitor window. Do that by choosing Tools and Serial Monitor from a menu. You should see something like this. If you're not sure what the PS state variable is actually doing, do this little experiment. Modify the sketch by replacing the lines in between the curly brackets, the segment of code starting with if PS state equals low, with only serial.println (motion detected), and the lines in the code starting with if PS state equals high, with only serial.println motion entered. Upload the edited sketch. Open the monitor and activate the sensor by waving your hand above it. What can you see in the monitor? You can calibrate the sensitivity and amount of time that the sensor stays activated by turning the two small orange knobs. Experiment with them to see the effects they have on the sensor's output. That's it with the PIA sensor for now. Please attempt the quiz questions before continuing with the next lecture, where you learn about the ultrasonic distance sensor.